No! Hey, it says live for the last 12 seconds. Yep, the old man thing. I wanted to talk about some of the right to repair and things that I've run into over the past, well, 2 years for the most part, but actually my experience goes back to 1980. I get out of Cobblesville College and started at Brockport, the former Brockport Ford Tractor. I don't know. They moved and then reorganized. As the original owner ran off with a secretary somewhere. You can't make this stuff up, man. But and I've worked with some of the aftermarket stuff. This is a JAL test by CNHi. They're out of Spain. And I worked with Texa. This one's hooked up ag only. And then I found out that there's a lot of ag stuff that's not in it unless you buy construction. Yanmar? Please? So anyway, that's some weird. I know Yanmar's mostly construction with their engines, but they're tractors. Ag. So one of the deals that I've had here. Let me disconnect this. Just to give you an idea that I have had experience with this stuff. Now on John Deere, quite often when I worked with their stuff with the JAL test and the Texa both went through diesel laptops, which is unfortunate. If I'd have known before what I know now, and it still would have been difficult because I need some more information, but I would have gone direct to either Texa or JAL test. Because I found out once that diesel laptops is involved, they won't hands off. Kojali won't even, they'll just say, nope, call Texa. Literally, twice. So we can't help you, it's Texa. Or it's diesel laptops is their problem. And hang up. They don't care. They don't want to hear it. Yeah. Isn't that wonderful? They said, well, just call diesel laptops. They're a big, no, they're not. They're not that big and they're not that good. Speaking from experience. I've had this for at this point in time, I had it how can you say it, registered for 2 years. And then I stopped because there was no way it was paying. And your upgrades kept getting more and more expensive. $3,000 a year. You got to do a lot of checking for that. Now, I thought I had a bunch of markets, is why I bought it in the first place. And for me, I had the money at the time, and it was a curiosity. So I thought, let's get the thing. Go out and see if I can develop something. And I went out and knocked on doors, and not a thing. Only had one that if I wanted to come check my unit, more than welcome to. So here we are. What about the right to repair? Well, a lot of what they're talking about is semi-bogus, but overall, it's true. What do I mean by that? Well, Deere doesn't have to come calibrate everything. Deere's programming is pretty simple. And one of the problems with Deere programming is that things need to be calibrated because their systems are cheap and sleazy. Okay, I'd say that with all, how can I say it? All due respect. When I went to Komatsu when we had trouble with a sensor, there was a recall on a particular sensor. They didn't give us the actual full data. They told us that we were supposed to go, so we went in and looked under technical service bulletins, TSB. Couldn't find anything. Buddy of mine that was working there couldn't find anything. So after a while, they needed him to go do services instead of this relatively simple repair, and sent me out. And he said, you're supposed to recalibrate them. And I said, yeah, that's funny. So what do you mean? I said, I put these in before. Yeah, but this is a recall. And I said, yeah, I know. It's the same unit. I saw it. How do you know? I said, I just trusted the same unit. I'll be okay. Well, all right. Besides that, I got the numbers. I'll be all right. And he says, yeah, but you may not have service down there. I said, you are correct. It'll be fun. Well, to give you an idea, with a Komatsu foot throttle, the foot pedal sensor, whatever you want to call it, it actually has 5 words in Spanish. Sorry, can't help you, dude. What did he? I only knew about 3 words in Italian that a lady taught me. And the one I remember most is kikidi-ki. Shoot the rooster. Anyway, when I went out to do the recall on Komatsu, and they finally told me after the 5th pedal that I replaced, 4th or 5th, that you're supposed to recalibrate the bugger. And they said, oh, how you been getting away with it? And I said, what do you mean? I turned the key on, wait for everything to reset. I pump the pedal slowly up and down 3 times. Give the computer a chance to look it over. Then I shut the thing off. Then I turn the key on. Then most of the time I start the unit. No codes, no problem. Well, everybody else trying to figure out how to recalibrate it. Yeah, I said, because the idiots say recalibrate something, A, that's already built within a range, because it's a very expensive part, and that's one of the reasons it is expensive, is it's built properly within a particular range. You can take recalibration means that you could take the same unit with a broad range of, how can you say it, specifications in it. And then you recalibrate that to the computer. This is 0. This is full. Okay. This is what happens halfway through. And when you get through with all of that, and with the different positions, you've got it calibrated, and a unit that is suspect or even in poor calibration itself can actually work with a controller. And the controller just needs to know, hey, this ain't right, and it'll throw a code immediately, recalibrate it, all done. Komatsu did that early on, and then later on they just decided, what if we get things built to spec? Who knew, right? Design your computer to handle a different range of variances, stay within the variance, and sell the part. Problem solved, right? No need for right to repair, no need for software, nothing. That's right. The only reason you need recalibration is a part is built is either far too expensive to build within a tight unit, or they're just too cheap and sleazy to have it built within that particular range that they've designed their controller's software to handle. Now, one of the things I purchased years ago was Mac had an HD code reader. I've got it buried in there because I haven't used it in years. And they like to use the word powerful, but it was a good unit that would dig a lot of codes out. I mean, codes that sometimes even OEM would have trouble pulling out, but they had to be SAE, generic SAE, Society of Automotive Engineers codes, standardized system. J1939 system, but J1939 off-road. That's different from on-road, and sometimes the whole entire fault code is different. Now, the thing that I had with Deere, which was amazing to me, with the HD code reader, it did pretty fair. But then I bought this unit for, I think, a little over around $500 and something off the Mack truck, which I probably shouldn't have done. I'm probably still paying for it a year later. But I've only used it a couple times. But this thing pulls up generic codes, and if it's available, we'll put up all your running data, your monitoring data. It pulls up an awful lot of it on a couple of John Deere that I had there. And on one Deere, it pulled up a code that was a body code, as you say, or drivetrain code. I said, hey, look, and I found that on the HD reader. This one would pull it up as well and told me that it just simple speed sensor for the transmission and rear end wasn't giving it accurate mile per hour reading. So there's a lot of Deere codes I pulled up, and I sat there, right to repair? And I'm still a little bit baffled because I understand why these guys want it. The dealer's 100 miles away quite often out in the Midwest or Mexico, as they were talking with Deere in Mexico having a little bit of a spat and a spit. And Mexico went about it the wrong way. They should have just plain old-fashioned taken them to court, but they just didn't even bother to warn Deere. Shut them down at the border, inspected every machine, and failed it. Kind of like our DOT here in New York State. If they pull you over to inspect you, that means you are getting a ticket. They just haven't found it yet, which is constitutionally illegal. But nobody will step in and do anything about it. Still, there we are. And Mexico's pulling those stunts as well. However, this thing could get the farmer the code. Now, here's another interesting thing that I ran into with these. I had a machine that had a problem, and the farmer would turn a PTO on and nothing would happen. And he couldn't figure out what was going on, and the PTO wasn't working, and then he just started moving because, well, the PTO ain't working, I'm just going to go back. So he let the clutch up, started to take off with the PTO engaged, and the PTO started working. So I started giggling a little bit and laughing. I said, what do you mean? I said, well, there's an odd code in here without a definition. That's John Deere specific code. It was a seat switch code. And some of the seats have 2 switches in them. Some of them are for 2 different controllers. Some of them are to be sure that there is a code sent to the controller. The operator presence is what they like to say. Your fanny's in the seat type of thing. And as it turns out, that's what the deal was. And I was able to surmise that by the use of this. Well, actually, the HD code reader, as well as, which did just as well as anything in here as far as pulling codes. The Bosch units, both of them bought from Mac, did every bit as well pulling codes as this. At $8,000 3 years ago. So bang for the buck. Go to your Mac tool truck and buy one of these. Well, I can buy it offline. You can. Maybe even a little cheaper, but I doubt it. However, if something goes wrong, and if you are an actual working farm and you purchase this from your local Mac dealer, he will be happy to take care of you, because this isn't the only thing you'll buy from Mac. I go to Harbor Fake. No. I will say this about Harbor Fake. The former Kermit and Myron Fassett farm out in Springfield, New York. Both of them taught me the same thing, because they were laughing at each other. They had totally different personalities, totally different thinking styles, and both of them said the same thing. One guy says, I spend nothing unless there's a reason for it. You're too cheap. He says, I am, proudly. And Kermit says, and I spend too easy. And they both laughed and looked at each other and said, we meet in the middle and come up with some pretty good ideas every time. He says, because I pull him back from doing something crazy, and then sometimes he's got the right idea, and it's just scary when you're looking at the money. But we need to spend it, so we do. That was a partnership. Let me tell you, not out of blood, sweat, and tears, though. So, Harbor Fake, they taught me, it grows just as well planted out there in the cornfield as the Mac Snap-on or whoever else's. Just saying, they wouldn't even buy Sears Craftsman. Don't tell me about their Icon and their others. Just don't even bother. Don't go there. If you like them, enjoy them. But no. Harbor Fake may have one of these you want to try. No, it's not heavy duty. You need the heavy duty. This is mainly built for over-the-road trucks, period. But they use the same J1939 basic system. But one's on-road, one's off-road. But they have common codes. So this pulled up a lot of, oddball tractor stuff. And some of this is powerful enough to pull up the Deere some of this Deere specific codes and not give you a real direct answer for it. And a case 580, what was that one? M, I think. This gave us an idea, as well as my HD reader, and another one I have that I don't have in here. It's out in the car. Is a Nexic Blue Mini. It's just a little stub to go in a 9-pin. Plug it in a 9-pin. It didn't tell me, like it should have, that there was a code in there for a speed sensor. Didn't. Or temperature sensor, sorry. A case-specific temperature sensor. However, it had in the data on a little Nexic Blue Mini, a couple of $100, it showed that hydraulic oil temperature -30. We knew the sensor was bad. It was 70 or 80 out at the time. So there we were. It had an actual data list, but it was a total data list. And all it would do is give you a reading on what was available. So the Nexic Blue Mini even did quite well in the past few years. I would guess by now that's up to $350 or so. From under $1,000, you can pick up a bunch of these things that'll help you with your codes. Now, the other guys are out there saying, no, wait a minute, we don't even. You are correct. A lot of the new Deere monitors, if they allow you to get into them and show you how to do it, will pull up the codes for you just as easily. Uh-oh, I'm getting buzzed. It's nothing. Okay, you ever get those? You just get a buzz and there's nothing there. I get that too often. But anyway, that's what you're looking for, and there's only a certain amount of availability, and even in your automotive side and in the truck side, like I said, there are certain dealer or company specific codes for their systems that are available. So you have to take all of this aftermarket stuff with a grain of salt. Take the idea of this with an axe. if you have a fleet, it might work out well for you because it pulls up some repair data. It pulls up some wiring schematics, not diagrams, but schematics. It pulls up some component locations. It's all, they keep giving you an excuse. Well, you paid $8,000 so we can continue to upgrade. Paid $8,000 for what's in my hand. It wasn't worth it. Say, then why would you? Because I would recommend, if you're going to do it and you're on the farm, to do yourself a favor and spend the 10 or 12,000 and get the whole ball of wax. The connectors that you need, which are rare anymore other than a 9-pin connector for these, except for your Kubotas, your Yanmars and such, they have a different connect. Each has a different connector. Deutz, if you have specific engine connectors other than what's in the machine itself. Deere, you plug into the 9-pin, and even if it's somebody else's, I ran into that with some of the small loaders, were Liebherr, and Deere put their engine in it. Trust me, but it made it a lot less. So you could go in through the 9-pin and do everything but reprogram the Liebherr controller side. So these things are still most of everything through the 9-pin connector. And I think one of these actually had the Cars OBD2 trapezoid thing in there, or semi-trapezoid. Anyway, to continue on with that, I just figured I'd toss that out there as I looked at the Deere and the other, and they're talking about repair problems. The problem I'm seeing more than anything else is the OEM specifics. But lastly, on this end of it though, last but not least, I'll say that the federal government in the past, specifically in the 90s, and specifically in the 2010s, had made some major changes, and specifically in the late 1970s, made some, when the EPA was actually literally opened up and founded, they made a disaster of regulations for emissions for these engines. Disaster. They jammed in regulations when they heard, we want this. Well, it's not available yet. You're going to make the technology or you're not going to sell it. So the feds have been, you can holler at the companies all you want. The feds have been the major problem. If there's any emissions trouble, all of these companies, on-road, off-road, are supposed to cover that emissions for up to a certain amount of time. I think in ag and such, it's like 5,000 or 10,000 hours, and on-road stuff was, I forgot, 150, 200,000 miles or something. I mean, it's a fair amount of time that they're responsible for all of any emissions failures whatsoever. So you go to your local dealer, you might have a dealer that stiffs you for all of it, and then as they get paid, pays you back because the major company is going to stab you because the feds have stabbed them before, in perpetuity prior to even the technology coming to bear, to even be tested. Airbags, anyone? Chuck Schumer here in New York was the worst one ever. I was there listened to a GM engineer at a fire service presentation tell us that Chuck Schumer was the worst, who forced airbags into cars, telling people, and he said, we can't do this. It'll kill more people than it helps. And Schumer says, we have to get safety started sometime, and you'll get some data from it. Yeah, data from dead people. Literally. That's not conjecture. I was at the meeting listening to the engineer. So this is how the federal governments have been operating. The Tier 3 systems, they were easy enough, but not that great. We had a lot of trouble with them, didn't we? Yeah. They had to, because the turbo ended up on most machines, wasn't wastegated on the larger ones. It was variable geometry, as they call it. Cummins had a little nozzle that would move in and out and change how the air was brought, or the exhaust was brought in, and others had movable vanes, and they all had the same problem. They would stick. How do you lubricate something? You have to find a way to dry lube it or no lube it and have the carbon not affected. The particulates in the exhaust. What they immediately did was come to a particular level of emission standards, and the problem came in they didn't consider the cost of getting there. And I don't mean necessarily money cost. I mean the cost of pollution of producing the equipment to cut that emission standard to meet it, but also the cost of afterwards. What type of stuff are you throwing in the landfill when you're done? You have to recycle. That also is a pollutant output. You didn't think of any of that. So you're out there with mechanically turbochargers operating under severe heat. They have to be cooled now with coolant from the engine, as the one guy used to call it, heated coolant, running through the turbo itself and the actuators. I mean, we're talking, they put crap on these engines. You can't find the engine anymore half the time. Speaking from experience of trying to work on these things, trying to find a controller is a treat on some, unless they put it somewhere else on the rig, which more of them are starting to put it underneath dashboards and such. But if you have a Cummins built engine stuck in something else, Cummins, Detroit, Cat, they're going to put it on the side of the block unless you make arrangements otherwise where they can run the engine to be sure it works. So the idea of actual full emissions and pollution problem, they only considered one side, what's coming out the exhaust. They didn't consider what's on this side. Let me give you an idea of Tier 5. They don't know what to do. They're meeting Tier 5 emissions with injection nozzles, injection pressures, changing the size and scope of the combustion chamber, changing software. So in most cases, you still have an EGR valve that they're trying to get rid of because of the cooled EGR going in there. So now they're going into camshaft timing to try and close the exhaust valve with algorithms in your computer. Software, again, that can fail and has to be updated. So they'll close the exhaust valve early to keep exhaust in there while you're trying to blow fresh air in there to get the engine to run, to get rid of the EGR and the EGR cooler, which the coolers have been problematic since day one. Leaks because of temperature differential and the crap that's in them that's corrosive just in the exhaust stream going there. Then the valves to handle what goes in and what. I mean, when they got back, the actual reliability of the base engine was fine. Everything we've been adding on since has been problematic. Common rail systems, when they came out, their controls weren't ready yet, nor was the longevity. They had you buy a dozer, a D155AX-5 Komatsu dozer with one of the early common rail systems. And it was just after the serial number break, because before that was the old-fashioned jerk pump. Never heard a problem from one of them. But common rail, we chased that. If you didn't have perfect fuel in there, it ate it up. In 5,000 hours, 4,000 hours, we had 2 pumps and 3 sets of injectors. The injectors were part of a tune-up at 4,000 hours. Said they will wear out by 4,000 hours, and they do. What happens? It takes too much fuel to go through into the system, which makes the pump overpump, but not necessarily to a severe extent for the pump or the injectors, but it exceeds the algorithm in the controller. So it throws codes and derates the engine. And there you are with nothing. And technically the engine's running beautiful because the worn out injectors are opening early and closing late and fueling that puppy into some kind of horsepower. But it's no longer Tier 2. Then you put an EGR on top of that, and they improved the reliability of the pumps and the nozzles a bit. But still, they got replaced much earlier. Well, now you don't just have an injector, pop-it inject nozzle. Now you have an actual electronically controlled pop-it nozzle. I mean, the amount of extra production for this negates anything that they take out of the exhaust stream. But they don't care. They want that exhaust stream cleaned up. We're going to pollute the land and pollute the air in production before because of all the polymers and everything else that's involved in it. That's not regulated for its output, is it? But that exhaust pipe is. All 2, 4, or 6 inches of it. And when you're done with those parts, where do they go? The landfill. Well, now they have to put membranes in to protect the leaching and runoff from that. What are we doing here? DPFs, because I haven't got that far yet. Got into the EGR coolers that they can't recycle. They're rotted, so they have to toss them and let them rot. Where? In the landfill. It's not like it's exotic metals that they can go in and melt down and do something. It's landfill. What do they do with the extra injectors? Well, they take them and rebuild them. Sure they do. And the stuff that fails, where does it go? The landfill. Your turbo goes bad. They got to throw the parts out. Some of the metal can be recycled, but for the most part, where does it go? Because they're small parts that are hard to handle. The landfill. What was our biggest problem before all this started? 1960s and 50s. The landfill. Can I tell you? So let's carry on with this. Tier 1 was pretty much, they put aneroids, as we used to call them, air-fuel mixtures on them. Tier 2, they started raising compression ratios and getting higher pressure nozzles, more holes in them, etc., etc. And most of the engines had to go to common rail systems for more precise controls. So now you're computer controlled. Than a majority of them, depending on the horsepower. The lower end they did nothing with. The upper end they couldn't do anything with. But in the middle, usually someplace around 100 horsepower, up to someplace in the neighborhood of 700. So they did that. Now, when they get through with that, they're going into EGR. Let's see, Tier 1, yeah, AFC was a fog control, cut down the smoke. Number 2, they were trying to cut it down a little bit further, but they were cutting down particulates as well as hydrocarbons and NOx emissions. So they were controlling at a more precise rate. Now you're into your Tier 2 is into common rail systems. When they go into Tier 3, now they're trying to cut the NOx emissions down as far as they can, with as simply as they thought they could, but they demanded EGRs on almost everything, unless you could come up with another system, camshaft control most of the time, that would assist in reducing the NOx emissions as well as your particulates and hydrocarbons. So they keep fumbling around with that. Now, Tier 4i that they had came out with catalytic converters and DPFs. They're trying to reduce particulates to almost nothing, and a DPF take the particulates to nothing further, as well as the catalytic converter before the DPF was also supposed to take down more of the NOx emissions. However, they had trouble with the catalytic converter because it was so fine-holed to get in the exhaust stream stretched through it. Now you have restriction, and you have a diesel particulate filter, which too is ceramic, but it's porous ceramic with cells next to each other that are deadheaded except for the pores between them. Porous ceramic. So now you have restrictions higher than the actual muffler, so the engine has to work harder, which means in each step that they've gone up here, they burn more fuel. How do you have less emissions when you're putting more fuel through the engine? It was a crack because of their measuring system. They were able to say we're making a change, parts per million, right? But you're taking more, 1 million units only has so many parts in it. But you see that unit? They're putting out more units. So it didn't make any serious changes at all, ever. When you measure by parts per million, all you have to do is blow air in the stream. Ooh, look at that. The solution to pollution is dilution, is what's been said for 50 years. That's an engineering quote. So when they get done with all of this, the catalytic converters are problematic. The DPF is terribly problematic. You had sensor probes and a differential pressure sensor, as well as algorithms in the controller that would give an idea roughly of how much fuel had been run through the machine and get an idea how much was put out as far as particulates to know when to regenerate both the catalytic converter and the DPF. Because the catalytic converter had to be clear to take care of the fuel in the stream to cause enough heat to burn the particulates out of the DPF. And then because the DPFs are horizontal, the ash stays in the tubes on the lower side. Those parallel tubes. It stays in them on the inlet side. So you hope that by banging and rumbling around that it knocks some of the ash down into the container. But there's not much room in there for that. So it starts plugging from the bottom up. 4,500 hours was demand. The first change was supposed to be free. That's never free. That meant it went into the cost of the machine. The customer paid for it before they ever received the machine. No, it came out of the corporation coffer. Where does the corporation's money come from? Sale of the machine. You stupid political dolt. You lying sacks of crap. So there we are. The differential pressure sensor I had on one machine in one of the earliest froze on a 40-ton haul truck. Why? Because the lines they put in there came out from each side of the diesel particulate filter, the outlet and the inlet. There's differential pressure. When it reaches a certain differential, too much pressure compared to what's going out, then it starts into a regen to cook it out. Well, moisture got in there, and the tubes were horizontal and straight up and into the pressure sensor unit, which is kind of funny. You say, why? Well, because of the way it was designed, the tubes froze. But this one, because there's no vent, moisture made its way up into the unit itself because of the pressure in and out, and pulses and such, and froze the sensor. He says, yeah, we got a recall on that. And I told him, I said, who in the world dreamed up this Rube Goldberg thing? I said, how's that supposed to drain any of the moisture that's in the exhaust, which water vapor is a large constituent of exhaust. All exhaust, of all combustion, everything. So you sit there, he says, I know, we've been trying. I'm trying to put that thing in there. I was supposed to take an entire unit off the side of a truck and spend something like 10 or 12 hours, some ridiculous amount. I found a way to sneak my hand in there and get it done without tearing the whole thing off the side. It was terrible. You can't do that. Okay. I'll go home for a few hours. I'll come back later. No, you can't do that. The other one was the temperature sensors were failing. They weren't up to snuff even at Komatsu's level with Bosch units. So temperature sensor failed, differential pressure sensor fails. Then any stretch of the imagination, it's immediate derate. Immediately. It's just over. It's derated. Which, with a diesel, with a DPF, the diesel particulate filter, is probably a decent thing, but they always derated too far. The longer you run it, it's already trying to regen. Your temperature probes, your differential pressure sensor went bad. The temperature probes are there to protect it because when you're burning it out, the outlet, even the inlet of it, because you're coming through a catalyst. Quite often they had 3, but they whittled it down to 2. They'd have a temperature sensor before the cat, temperature sensor between the cat and the DPF, and then one on the outlet of the DPF. And if any one of them failed in any manner whatsoever, even just one of them reading too far out of range, immediate derate. And maybe you need the unit to run to continue to burn the DPF out because they've been hitting the button to stop it from doing its regen so that they didn't have too much critical heat in the wrong place to burn something else up. So where's you get this. I mean, what we were doing here, what we're still doing is cockamamie. What do they do for Tier 4 final? Most Tier 4 final ended up being SCR, supplemental catalyst reduction. Now you've gone from AFC fuel control into common rail systems, then you've added on an EGR. When you got through a Tier 3 EGR, now you're adding in at least a catalytic converter, possibly, and most often a DPF, diesel particulate filter. In a few cases, they were able to have the catalytic converter alone in certain horsepower ranges took care of the parts per million, not the actual output, but the parts per million that went through there. Then you get into your DPF. Now, at this point in time, everything is increasing the fuel use. Everything. Because it's exhaust restriction. Now, they're able to take because they have after treatment to meet standards that they wouldn't allow them years ago. They wanted to run standard engines and put the after treatment on them. And our federal government freaked. They almost put 2 companies out of business for that. Cat actually went and requested it and got fined for requesting it back in the late 90s. That's how bad this whole situation is. So now that we're up to Tier 4 final is basically Tier 5 without the final segments of Tier 5. Tier 4, the whole thing was a crock. They put in a supplemental catalyst reduction. Now your DPF system, I remember I said extra fuel. Extra fuel came in either with a doser nozzle. They literally pumped diesel fuel raw into the exhaust stream, the heated exhaust stream, to go through the DPF. They go through the catalytic converter first to clean it up and heat it up, and then go through your DPF now, all that heated exhaust going through. Or they would do it with the Cummins B, L, L9, and C series. You know, the B67s, the late 59s, then the C 8.3, the L9, they use the injector. They'd have 3 injections, literally. At the bottom of as the exhaust stroke started or partway up the exhaust stroke, they'd throw in a 3rd injection, and it'd be metered to go through and clean up your cat and your DPF. So fuel's coming from here, raw fuel, heating everything up all the way through it. So more fuel is being burned. Not in a combustion chamber either. So is that not going to create products of combustion? And it did. Some of the systems are even worse. They didn't just send raw fuel through there to heat things up, because the catalyst with that raw fuel would heat things up without making a flame, by the way. They had flame systems with actual literal flame throwers. The catalytic converters crack. The heat systems would fail. I mean, we're talking cast iron flame chambers. Insane stuff that was going on to do this. So what do you think the complexity of it is? Problematic, going in a landfill. What are you going to do with it? It's incredible. Glow plugs. I've been out there and seen some of this stuff, and fortunately didn't have to work on anything but the software side, chasing codes and finding out that they have to regen this stuff in a different system than your standard DPF system. The flamethrowers are terrible. Caterpillar had them in certain Fiat engines, and certain, what was that name of that? I don't know. Ford used them. Shibara. Kabuki Kun something Shibara. It was generally a good engine, but they put the flamethrower on that. Not cool. So now we got all this crap on there. The SCR has a doser now after the DPF. So you got fuel dosing, catalytic converter, DPF with temperature sensors and differential pressure sensors. Coming out of the DPF, now you've got a doser for horse urine, 32.5% urea. When it hits the flame or it hits the heat, it turns into ammonia. And it sends ammonia in the exhaust stream through a catalytic converter to try and get rid of some of the NOx emissions. Now, mind you, this stuff is ammonia, one of the most pungent, pollutant gases, chemicals possible. Ammonia kills, right? In the atmosphere, it's destructive, right? It's horrible to humans. Goes through the catalytic converter. It's so bad that they have to put a capture catalyst to catch whatever ammonia is not used up as much as they can before they send it out into the stream. Leftover exhaust, leftover NOx, leftover hydrocarbons that are still going out into the atmosphere, carbon monoxide, carbon dioxide, all that's going out, and they can't catch all the ammonia, and some of the stuff doesn't have the capture converter on it. So when they're done, there's raw ammonia going out into the atmosphere. Tier 5, all of them will have it. The end of Tier 4 final, all of them, I believed, had it. So what do they do for Tier 5? There's not much else they can do. They try and tighten up everything all the way down through. But what they've actually done is one of the most sinister things in history that you could ever imagine in most cases. And Europe did it before we did here. They took the DPF out, which sounds good, correct? But instead of dosing these 2 little catalytic converters in Tier 4 final on your SCR system, occasionally to clean them out when it was under certain horsepower loads, etc. What happened later on was something they had early on in the European system. They take out the DPF, change how they burn the fuel with the EGR in the engine, and in some cases they're able to get rid of the EGR because they have a massive catalytic converter, and after that, the SCR system, they pour that urea into it and send it out through the cats into the atmosphere. Yes, they try to catch all the ammonia they can, but they just pour it on. It's continuous, nonstop. That's why you see that the SCR blue tanks, blue DEF fuel, or blue DEF on the side. That's why they've gotten larger. Got rid of the DPF regen. Now, every so often, you're supposed to do an efficiency test on the supplemental catalyst SCR reduction system on the end for the NOx emissions. No, you know what else I missed? Sensors. That's right. NOx sensor, doser, catalyst, capture, and on the other side of the capture is a NOx and an ammonia sensor to change the dosing. Ammonia is so bad they have to put a sensor in there to prevent all the ammonia going out into the atmosphere, which is more dangerous than the exhaust itself. Well, why have I gone through all of this for 41 minutes? I'm going through this for 41 minutes to give you an idea that is sinister, evil, disgusting, putrid is the parent company of Case New Holland Industrial, CNHi, which is Case International on the ag side. But overall here in America, it's CNHi, Case New Holland Industrial. The parent company is Fiat. Fiat has worked with Bosch systems for decades before I was born. And a lot of these systems, including the common rail, originated from who was it? Was it Fiat? I think originated from the Fiat systems, and Bosch finished them off. They just buy their systems from them and continue on, because they didn't just like, hey, yeah, we got something that works here. You want to buy it? Okay, and Bosch makes it work. Just like Cummins and Komatsu, they work together on engine designs and such back and forth. So these guys were doing something similar too. So for many, many years, they've been coming up with all of these systems. The problem is our EPA here in the United States, as well as over there in Europe, they're putting restrictions and everything on there that make the manufacturer responsible for this. So while you're saying there's the right to repair, yes, there is. You supposedly bought the machine. It's yours. Take a broomstick to Deere and shove it in some orifice that they might have and tell them that's my machine. However, Deere is responsible for certain parts of that machine in perpetuity to the federal EPA government that's worse than the IRS in many circumstances. So what are they supposed to do? Of course, they've gone overbearing. There's no doubt about it, because they can. And the feds aren't going to touch them because they get what they want. You are being hyper-monitored and oppressed down here. Doesn't matter your machine's sitting there for 6 months. They don't care. It's not their problem. If it's not running, this is no lie. If it's not running, it's not emitting emissions. That's the way politicians think. You'll just have to wait. It's not their problem. Especially on the left side of the aisle. They don't care. It's not their problem. That will not put out emissions. But it'll sit there and rot, so they'll need other repairs because it sits, and electronic systems do not like sitting long at all unless they're covered in controlled storage environments. Trust me on that one. They've improved, but not that much. So here we are. Right to repair, you own the machine. Darn right. The claim is Kubota lets out all their information, I'm not buying that either, because I've never seen anything where Kubota would allow their Diagmaster out. And I think they do have a section that can go to the customers, but it's limited. There's only so much they can do in that thing. Why? Because Kubota's responsible for everything emissions, which they keep backing up into the engine all the way down to the fuel high pressure pump. Seriously. For not quite in perpetuity, but for so many hours, 100 hours, thousands of hours, whatever. So this is ridiculous. You bought the machine, it's yours. Once it makes it through warranty, it's totally yours. They should hand you all the information for the data that you go in, the monitoring and all of that. They should tell you that, for $2,000, you can get yourself your own diagnostic unit if you want, and you can work it just like we can. And if there's any other trouble that's major, that's really serious emissions and internal, then you'll have to call us, which is stupid because you own the machine, not Kubota. But the feds don't want you to be able to get in there to do that until possibly now. Just saying. There's been changes in the wind, and hopefully they make a difference. The other part we're going to have to deal with, though, as far as techs, I mean, I'm retired, but still, tech guys as well as you owners are going to have to put up with, and the dealers, is the changing winds. Yeah, you're going to say, well, Trump stirred everything up. He has, and to a good extent. It's going to be problematic. There's no doubt about it. Not going to say it won't be. And I'm sure that they very carefully kept Fiat out of the discussion. And Fiat owns CNHi, Case New Holland Industrial, or Incorporated, however you want to look at it. But last I knew, when I was going through service seminar stuff, it was CNHi, Case New Holland Industrial. That's their major. If you go to their website, how they put it. There's nothing about Fiat there, and Fiat owns them lock, stock, and barrel. But that's the North American part of the company. So that's to give you an idea that while you're looking at all this stuff with Deere and Case New Holland and whoever else does whatever else, Kubota's probably, yes, is probably the most free and open with what they're doing. New Holland and Case are almost identical machines. So, monopoly anybody? Yeah, they have a little different this, a little different that, and they made it available for different parts. That this guy was a New Holland, Ford New Holland, so they've got New Holland Blue and keep selling that. And over here was Case and International, and Case kind of had red for a little while, and now they're all red. So that was the original purpose, but after a while they all said the same thing. Pick one. The only thing that was good about it, though, is you might have a New Holland dealer 30, 40 miles away over there, and a Case dealer over here, and you're able to compete, pick up almost the same tractor. Yeah, get a better price that way. That's not necessarily a bad thing. So anyway, that's my take on all of this. I went onto Instagram and sent a message, and I know it's not going to go to him directly, but I sent a message in case it tweaks somebody to get it up to Lee Zeldin and EPA. Let him know that there's a lot of stuff that's going around out here that they need to drop this emission stuff on the ag equipment, possibly even the construction, because it's too restrictive and it's unreliable. Even in modern stuff now, it's unreliable, period. And why should you shut down an entire properly running engine when its after treatment isn't working proper? It's not the fault of the engine necessarily. If there is a problem with the engine to fix the after treatment, that's a different story. And you'll get the codes for it and the D rate for it. But if your after treatment system is failing, you shouldn't be shutting down the machines, especially in agriculture, in harvest time, or in planting. Neither one should have the problem. In between, find another tractor for your haying or whatever else. If you're a crop farmer, there's a big wide gap in most cases, but not all of them, because now you go from crop to crop to crop to crop to be able to make your buck. It's not like chicken and pig farmers where everything's a rush. Then you stop and hang out and wait for them to grow, and then it's a rush to get them to market. That's a little different world, but if they're raising their own crops, then they're in the same boat as everybody else. It depends on how you run your farm. So you can't sit there and just say, well, you farmers, where everybody's the same, or you farmers over here, well, maybe, maybe not. They all overlap into a certain way, and to sit there and say, we're going to blanket this because we're the feds and say so. But 9 times out of 10, the feds are wrong in every broad application they ever make. So, but the after treatment systems need to be removed. If they sat there and said, well, we need to put a catalytic converter on at least to do, okay, your modern fuel systems are set up to be able to handle that pretty well. But you need to get rid of the software and everything involved with the after treatment systems, from the diesel particulate filter right on through, needs to be removed completely. Because by the time you hit tier 5 and what they've done in the construction of the combustion chamber, in the fuel injection systems and the pressures and the algorithms for it, they can put multiple sprays in there, a start, mid, and end of injection if they want to. They've been working on that to try and get a consistent flame front in there to completely burn all of the fuel without maximizing their temperatures. But there again, it's going to happen. That catalytic converter can catch a lot of the NOx emissions coming out of there. But just like going back to the refrigerants we had in the 70s and 80s, they were complaining. Got to get rid of that R12. That Freon is horrible. But it wasn't. Somebody went and lobbied and got an R134 in there. And the R134, they had to remodel the systems. Not completely, but they had to resize the components and change the lubrication that was in them. So yeah, they had to redesign some of the materials in the system so they could survive with something akin to antifreeze for a lube. Because the R134 couldn't handle the mineral oil. R12 had two major things that kept it going well. And this is another emission standard thing that people don't pay attention to. R12 had a larger molecule, simpler systems, and worked under varying pressures quite well and was able to operate on mineral oil, which kept the inside of all those rubber lines and everything lubricated well. You're able to run a less expensive pump better. And R12 with a larger molecule had less leaching, or whatever you want to call it, release into the atmosphere through the rubbers and aluminum sections of the system. R134's systems, they had to redesign everything, because if you put 134 in a 12 system like we used to do, every year you will have to recharge it because the 134 goes out en masse 2 to 3 times more than if you just left R12 in there. And as one recycled lefty told me one time, he says, I hate talking to you. I said, why? He says, because you don't know any of this. You haven't researched anything. You just tell me what you think. And it came up right. And I said, what's that? He says, say on this end, R12 is the great Satan of all refrigerants. Whatever. He says, R22 is over here someplace. And all they need to do is redesign the system slightly to get 22 to work. But it is harder to work. It doesn't vaporize as well as 12. He says, if you're over here with 22 and some of the others, and he says, bring it all the way over here, and here's 134. He says, it's barely any better, and it's more problematic. And he says, it's a big joke, just like you said. He says, but you didn't know why. And I said, look at the circumstances surrounding it. And he says, I know. The politics and economics of it didn't make sense. And today they're putting refrigerants into machines that are not just flammable, explosive. So they can reduce the weight to meet the CAFE standards, corporate average fuel economy. That they keep putting in airbags on, making the cars heavier. So they have to take other materials out of the cars to make them unsafer. And this is the thinking of these idiots. And it continues. I said, well, they're just going to have to come up with something different. Like listening to Feinstein and some of these others out there in California. Mad Maxine and others. Adam Shifty Schiff, who's a pile of Schiff. All of these people. Every one of them keeps going on like this and barking. We're making it better for you. And they're not. Because in the end result, what do we got when we go in? Let's just pretend we start from the drawing board and go to the final resting place of that machine to be scrapped or recycled or whatever else. My 1996 Ford Ranger costs less than any of the newer cars with all their emission standards on them, all their safety features, especially an electric car. And the total pollution that 96 F-250 put out, well, that 300 cubic inch, which is not known for great pollution, you know, being a nice clean burning engine, but a great runner and 300,000 mile type of thing. Beautiful engine. What's that mean at 300,000? Even at 200,000, it's not in a landfill. It's not burning energy to recycle it. Before an electric car hits the road, it's polluted more than my F-250 did when it was taken out and dragged for somebody else to steal parts off of it. That is a fact that I've had too many people tell me about, going all the way back, even including all the emissions controls on the cars that we had in the 90s versus cars that came out of the 70s when pollution was considered. Even cars in the 60s. A guy had a fleet, 3-4 cars that were Oldsmobile 350s. One came in at 4,200 pounds, 4,500 pounds. Big long nose thing. I think one of them had a 455, 25 miles per gallon on the highway. That's a lie. No, it's not. 25 miles per gallon on the highway. Not all the time. His average was actually 20, 21. Because he didn't drive it perfectly, but he could get 25 on the highway. Nice straight long runs like we had up there in Rochester area along the lakes. Easy. Well, then what? Because it was cold burning engine, hydrocarbons and particulates came out the exhaust more than others. Smog in the cities. But out in the open country, smog wasn't even, we didn't know what smog was. The problem with the cities was the concentration of the smog. So who needed the pollution controls? Who would have benefited from electric cars, even in the 70s? The cities. What did they do about it? You need transportation on the buses, and you're going to get emission control on your cars. The buses were completely exempt. They puked out exhaust from those Detroit diesels and others in the back end of those things that barfed it. There'd be a cloud going down the street. They caused more smog than the cars would have if they'd have been driving and just cleaned them up through the time. The biggest farce, the first step they had for emission control was the Thermactor air pump system. There was no catalytic converter. They just pumped air into the exhaust, leaned it out, and said, our parts per million are down. But what they sent out the exhaust was both the exhaust and air. So the number of million units of air to measure increased. So the parts per million went down. The actual output never changed. Even through EGRs, even through catalytic converters, it's changed somewhat, but then it converted it over to a sulfur dioxide gas, rotten egg smell. So they had another pollutant to clean up. If they'd have just waited until we got into the 70s and 80s, into the fuel injection systems, 99% of everything they wanted cleaned up could have been taken care of, including diesels with their common rail systems, high pressure. Even if you had to put the EGR on there, on the diesel, it does better than the car, but still the same idea in both. They're trying to reduce the extreme temperatures of combustion. But if you still need to put the power out of there, guess what? And what is the biggest constituent in the air that those engines are breathing? Nitrogen. So they needed to find a way to convert what was coming out. And that's what they came up with the SCR systems. But the SCR systems are problematic and throwing ammonia into the air worse than the nitrous that was going out to begin with. The NO and the NO2, I think it was, that they were trying to get away from. They were putting out NO3 or NO something. I forgot what ammonia is, but it was awful. Now, the old catalytic converters, it was sulfur dioxide, acid rain. We're doing it to ourselves because they were too stupid to let the systems go their way through the capitalist system. People wanted clean air. They wanted better cars. They wanted better fuel economy. They wanted a more reliable car. And our capitalist system brought the Japanese cars over. Scared the crap out of them. More German cars. Scared the crap out of them more. By the end of the 70s, we were doing pretty good. There was a reason for it. We, the people, demanded it, not the feds. We wanted fuel injection because it was simpler than carburetors. Much simpler. But we needed to wait until the technology got there for them to operate reliably. I mean, Ford had a variable venturi system that dwarfed fuel injection systems. Why didn't we have more of them? Because they were not reliable. Carburetors would wear out. But boy, they would go, and the fuel on it. The guy was driving, what was it? He was driving an LTD with a family of 5 or 6. He says, I'm driving along 20, 25, 28 miles per gallon in a full-size car. And we're all just lounging in all the room. So how much emissions are actually being put out of that car? Just saying. So when the farmers get out there and you're looking at your dealer that wants to shoot you in the head, then I've blown an hour now. Think about it. You know, listen to your dealer a little closer and what they're going through. Yeah, they're going through the same headaches you are. And as Trump pulls these tariffs and was talking with people, let him go through his systems to fight with these companies and the foreign segments of these companies, because Deere is mostly made overseas, just like the Fiat stuff is, the Case New Holland. A lot of that's overseas stuff being imported over here, except for the very largest tractors that have foreign components from Fiat stuck in them, including their cursor engines, whatever they are now, cursor 2, 3s, or 4s, what. Just saying, there's a lot going on here, and we need to make a change one way or the other. And the other one is we need to change, huge, that goes back to the 60s, maybe even the 50s. All American manufacturers must meet agricultural ASAE standards in their hitches, their drawbars, and basic tractor designs. The foreigners don't, unless it's built here. There's a lot going on. Time to go.